Good afternoon, everyone, and welcome to Workshop 6 Scaling on Cardano with Hydra, part of the Cardano Hackathon Asia IBW Edition 2025, with Hack to Skill as our innovation partner. I am Nidhi, your host for today's session. In today's workshop, we will introduce Hydra, Cardano's high speed layer 2 scaling solution. You'll learn how to deploy and interact with Hydra heads, perform rapid off chain transactions, and commit final states to the Cardano testnet. We will walk through the practical examples, including payments, transfer, and advanced multi party scenarios. By the end of this workshop, you will have launched a scalable Hydra application and understand how to build high performance Cardano dApps. As a reminder, the total prize pool for the hackathon is $65,000 stablecoins, including first place, second place, and third place, plus bonus prizes such as Best Meme Integration in Action, Best UI UX, and Best Hydra Implementation. The key dates to remember, including registration, idea submission, and team formation and mentoring sessions, all underway, leading up to the grand finale in Bangalore on November 29th and 30th. Make sure your submissions are on track for evaluation. Today, we are honored to have two expert speakers with us. TY, smart contract developer, they will guide us through the Hydra technology demo and the workflow and answer your questions live. Over to you, TY and Sharon.
Thank you, Nidhi. Hi, guys. I'm Sharan. I'm the product lead for Hydra at Input Output. We'll be doing a workshop on focusing on how to build with Hydra today. TY will take the lead on it, so I'll hand over the mic to TY. Thank you, TY, for taking time to do this.
Absolutely. Hey, everyone. I'm TY, and I'm a smart contract engineer at Emergo. I've been in this role for about 4 years now, and it's been a really fun process. I'll be talking a little bit more about the Hydra solution on Cardano, what it is, how it works, how to use it, and I'm going to present my screen now and begin. Let's see. Is my screen showing up okay? Yes, it is. Okay, so let's start with an introduction to Hydra. What we're going to cover is understanding what Hydra is, which is a state channel. And to understand that, we need to first look at the blockchain scalability problem, what this problem is, and then we will move on to understanding how Hydra solves this issue. After looking at the problem statement, I have a demo ready to show you guys how you can really quickly spin up a Hydra network, and then you can interact with it. Then after the Hydra network opens, we will attempt to send some transactions within the Hydra network, and then finalizing the Hydra state, and we will be able to see the on-chain effects of finalizing the Hydra state. So let's take a look at the blockchain scalability issue. So blockchains have a really core fundamental problem. Blockchains want to be incredibly secure, and so they have to be decentralized. However, decentralization and scalability are direct opposites of each other. The more you decentralize, the less efficient blockchains get. It is just the nature of decentralization, because if you have nodes all over the world and many, many of them, and they all have to interact with each other, then it's very obvious that the blockchain is going to become slower. That's just how it is. But blockchains need the security, and so we trade scalability for decentralization. So that's how that works, why blockchains have this scalability issue. And so how are we going to solve it? So how does Hydra solve the problem? Hydra is a state channel. It's a very, very simple observation that if I have a contract with you that I pay you $10 a month, then realistically, if you're not in a rush to use that money, then paying you $120 at the end of the year would also fit your needs. But the main problem then is, how do you guarantee that I actually do pay you $120 at the end of the year? What if I just run away after you provide me 3 months of service, let's say? Hydra actually enables you to have a guarantee that I will pay you. So that is what Hydra does. It's very interesting how it does that. We'll take a look at the next page. Essentially, we have the blockchain layer 1 living here. And then the Hydra state evolves like so. And no matter how many transactions we go through on this layer 2, it doesn't matter how many transactions go through here, the layer 1 lifecycle stays the exact same. So there are 6 steps in total. And these 6 steps stay constant no matter what. So you can imagine if on the layer 2, I do 100,000 transactions, for example. If I was to do 100,000 transactions on the layer 1, then there would be 100,000 steps on the layer 1, and each charging a very expensive transaction fee. Well, I guess it wouldn't be very expensive, but at the very least, it would be expensive enough that some apps might not want to do that. And so what we'll do is batch up all of these 100,000 transactions, let's say, into 6 steps on the layer 1. So that's the really, really powerful part about Hydra. No matter how many transactions we do on the layer 2, the amount of transactions that we do on the layer 1 is always going to be constant. And yeah, hopefully that's been helpful and give you a better understanding of what a state channel is. And let's move on to our demo. Essentially, the demo is going to be very, very simple. Hopefully it's helpful though, because the setting up the Hydra node and also the Cardano node is going to be the most difficult thing, I would say. But also interacting with the Hydra head is sometimes a little bit difficult, because you have to wait for transactions to happen on the layer 1, which is slow, like I said before. So yeah, you'll have to bear with me while we go through the steps. We might have to wait a little bit during opening up and closing the Hydra head. So let's begin by looking at how we can make a Hydra network. So if you guys install Docker, and Docker has a really, really easy way for you guys to spin up a Hydra node. And I would recommend, if you guys want to, take a look at the documentation here at hydra.family. And it will tell you how to install these Docker images. And it's a much quicker way of spinning up Hydra networks instead of building it from the source code. and I will show you how quick it is here. But essentially, it just requires installing Docker and then setting up this Hydra node service Docker image. So you can get all of that information from this documentation here. So now that that is over, I'm going to just run Docker Compose up. Also note that a Hydra node relies on a Cardano node to be running at the same time, because we need to submit layer 1 transactions during these 6 steps. So during these 6 steps, init, commit, collect, close, contest, and fan out, every single one of them has layer 1 transactions that need to be submitted. And so the Cardano node is essential. So let's do Docker Compose up. And we might have to wait a tiny bit because my Cardano node is not going to be synced to the blockchain at the moment because I had my computer off for the night. Hopefully that's not going to take too long. I think it might have synced now. Yes, it should be synced. You can see the Cardano node and Hydra node is running. The next thing I'm going to do is make another terminal. Why? Because I want to run the Hydra TUI. So we can do that by Docker Compose run Hydra TUI. Now we can see what this looks like. This is our Hydra head, and it's a visual representation of the Hydra head. What is it status right now? It's idle, nothing's happening. So how are we going to interact with it? So I have actually created a front end, and I'm going to cd into it. And I'm going to npm run dev. So what will we see here? If some of you have attended the Cardano SDK workshop, you'll notice that I kind of reused the page for it, but I've adapted it to have some Hydra commands. So what we're first going to do is we're going to initialize a head, and then we're going to commit some money into the Hydra head. The other thing I'm going to do is to show you how quick it is to send money within the Hydra head. Then we're going to close and fan out the final distribution of UTXOs. During all of that, I will constantly be pressing this button because I don't have it set up so that I automatically ping the Hydra head for the UTXO set. So I'm just going to press this button to show you guys the evolution of the Hydra head. So let's begin by pressing initialize head. Note that because all of this happens on the server, the logs will appear here inside the server. So let's see. Let's start by initializing the head. So we are calling init on it. We might have to wait a little bit because the Hydra node actually submits a transaction on chain to mint a Hydra head token, as it's called. Let's take a look at the code that I have for it. It's actually quite simple. At mesh, we have a Hydra provider, which should work out of the box. You can initialize it by something like this, new Hydra provider, providing it with the URL. My URL is this, localhost 4001. And we can see that init head has completed. So let's take a look here. Simply get Hydra provider, which initializes this mesh Hydra provider instance. Whoops, sorry about that. And then we can simply call Hydra provider.init, initializes the head. Let's take a look at the TUI. What happens? The head status is now initializing, which is great. It is now waiting for some parties to commit some money into the Hydra head. So what determines what parties need to commit money into the head? It is actually within the parameters of the Hydra node. So if we take a look at this Hydra node here, we have the Cardano signing key and also the Hydra signing key. So this actually, if there's only a single participant, we can see there's only one instance of this signing key. We can actually add peers into the Hydra head. If there are other people, then you must add a peer configuration, and you'll be able to find more information about that inside the documentation of the Hydra head. But for the purposes of this demo, I've only created a Hydra head that has one single participant. So with one single participant, we only need to commit some money inside by one person. So I'm going to do that now. I'm going to press commit funds. Right. And so we have generated a transaction, and we have submitted the commit transaction on chain. Once again, we might have to wait a little bit here because this is a layer 1 transaction, and so it is very likely to take a little bit of time to confirm. But let's talk about what is happening here, what is committing funds into the Hydra head. So what is happening is I am putting some amount of money inside the Hydra head on the layer 2. And once it's in there, I can use it as if it was the normal blockchain. So we can see Hydra came back with a message. It is now committed. We have committed 100 ADA. So you'll notice that this is quite a large number. It is actually 100 million. And 100 million Lovelaces is 100 ADA. Every 1 million Lovelace is 1 ADA. So now we have committed 100 ADA into the Hydra head. Let's take a look at the Hydra TUI again. Nice. We have a open head now, and we have an active UTXO set of 1 UTXO with 100 ADA belonging to this address. Very nice. So what can we do inside the Hydra head? Very simple. We can submit transactions as if it was the blockchain, the actual layer 1. There's no difference at all about how transactions work in the Hydra head compared to on Cardano. So we can use mesh once again to make a mesh transaction builder. If we set a parameter called isHydra to true, this actually gives us the default protocol parameters of Hydra. What are the default protocol parameters of Hydra? It basically just sets fees to 0. So within Hydra, we can do very interesting things because it's much more efficient. There's very little decentralization, and so the costs can be very low. So what mesh does is if you set Hydra to true, we actually just set the transaction fee to 0. We build the transaction as if the transaction fees are going to be 0, which is great because they are going to be 0. We actually don't have to pay any transaction fees inside our Hydra head. And then if any of you guys have used Mesh before to build transactions on Cardano, you'll find this very familiar way of building up transactions using the transaction builder. So how this works is it will create a transaction output with some amount of Lovelace to an address, to the address specified within the function here. Very simple transaction. And then we have to sign the transaction using the wallet that owns the money. And then we can go on to submitting the transaction through the Hydra provider. Very nice. So let's take a look at how that looks like. So let's initially press this button, get UTXO set. You can see right now there's a single UTXO inside the Hydra head. And I'm actually going to send some money to my Eternal wallet here. So I'm going to copy this address here. I'm going to put in this address, put 5 million, because this is Lovelace's, which is 5 ADA. I'm going to press send, and on the server, it has signed transaction and returned the sent funds log. Now we take a look at the set. It has 2 UTXOs, one with 5 ADA and one with 95 ADA. That is the correct behavior. And let's see how fast it actually does this. So we can send get UTXO set, and it immediately confirmed. We have a new UTXO inside the head. And just for fun, I'm just going to do it again. Boom. And yep, you can see the updates happening very, very quickly. You cannot get this speed on the Cardano layer 1 at all. It's not even close. So that is the power of Hydra. You can send transactions inside, and the speed of it is just way, way faster than on you would get on the Cardano layer 1. And let's just do it one more time for fun. Yep, we have the transactions. You might not be able to see it fully, but yes, these transactions are happening very, very quickly and being confirmed. Just for fun, I'm going to send all the rest of the ADA to this Eternal wallet here. I'm going to send it and press the button. It has indeed sent as well. So let's take a look at this Eternal wallet here and look at transactions. You can see nothing's happening. It's even though I'm technically sending money to this wallet inside the Hydra head, the wallet actually doesn't see it. Everything is happening within the layer 2. So now that I have sent all my money to that Eternal wallet, this is the state I want to finish in. So I'm going to close the head. So this finalizes the state of the Hydra head. So let's close it. So we received a Hydra message from close head. Close command was executed. Now, here comes the interesting part. We can see that the head status has been closed, and there's actually some remaining time to contest. So what is contesting? Essentially, Hydra nodes work on the premise that none of the participants actually trust each other. But even without the trust, there is still a very, very strong guarantee that the money is going to be sent in the way that the Hydra head state is at the end, because of this contest period. So if someone attempts to cheat and essentially make a UTXO set that doesn't look like exactly like this, and the participants don't agree, someone can actually contest it with the actual real Hydra head state, and the smart contract will automatically update the final Hydra state to the correct one. So if you have nodes, the Hydra nodes should be observing any closing events. So if someone tries to close the Hydra head, everyone has 60 seconds to submit the actual valid Hydra head state if the person closing the head was cheating. So yeah, there's a very, very strong guarantee that nobody is able to cheat as long as the contestation period is sufficient. So 60 seconds is actually relatively long. People should be able to set up servers so that they can react within 60 seconds. So yes, after the closing event emission, we can now see the head status is now in fan out possible. So what fanning out is after closing the head, we have finalized the exact UTXO state that the Hydra head is in. And fanning out actually gives us the money that is within the UTXO state. So once we fan out, we should be able to see some transaction here that will give us 100 ADA because we have sent this wallet 100 ADA. So let's see if that works. So I'm going to press fan out here and see we have some response from the Hydra WebSocket. And we should be fanning out the head now. Unfortunately, the fan out takes some time because it is also a layer 1 transaction. Hopefully, it doesn't take too long. Has it finished? Yes, it has. So the head state is now final. It has told us what the exact final UTXO state that we fanned out the Hydra head is in. So we can see these 5 ADA outputs that we sent because I was just pressing the button for fun. And then with the final 80 ADA transaction that we sent. Let's take a look at our wallet now. We can see 2 seconds ago, we received 100 ADA. So that is the power of Hydra. You can see very clearly that if you remember, I had initially sent 5 ADA, another 5 ADA, 4 times, and then sent 80 ADA. So these were 5 separate transactions within the Hydra head. However, inside the layer 1, it happens all in a single transaction. I received 100 ADA in one transaction. This means that I saved the transaction fees of 5 different transactions. So if I was to send 5 ADA on layer 1, send 5 ADA on layer 1 again, and I was to do all of these 5 transactions, I would have to pay transaction fees on the layer 1 5 times. So now that I've basically used this Hydra head to batch these 5 different transactions into one singular one that gives me 100 ADA, I can pay only one singular transaction fee. And it's also very interesting because the speed at which I was able to do these 5 transactions are way faster than I would if I was to only submit them on the layer 1. So yeah, these are the promises of Hydra, like how we batch some transactions, which is essentially what I was saying before. If I have a contract with you where I pay you $10 a month, if you're not in a hurry to use that money, we can use a Hydra head to batch the transactions so that I pay you $120 at the end of the year instead. However, because the guarantees of the Hydra head are so strong, it might actually be possible to simply have everyone you want to interact with inside the Hydra head, and then you can send them money within Hydra, so you don't have to wait until all the money is inside the layer 1 before transactions can happen. If me and you and a friend is also inside the Hydra head, we can simply use the Hydra head as if we were sending each other money completely and without even needing to trust each other at all. So that is that's a very brief example of Hydra. And we can see the power of it because we can see the wallet just getting a 100 ADA in one singular transaction instead of 5 separate ones. It's quite a short demonstration, but I really, really recommend you guys, if you guys want to learn more, please look at the documentation inside Hydra.family. If we get into the tutorials getting started, you guys will very rapidly be able to do what I just did. Make some transactions inside the Hydra head, play around with it. Yeah, maybe you can make an app, maybe a small payment app or something along those lines, because some payment apps might require very, very rapid transactions that isn't going to work on the layer 1, because an example would be something along the lines of micropayments, for example. If I wanted to, let's say, do a streaming service or something, and I wanted to pay for every little bit of data that I stream, then Hydra might be a very good solution for this, because you have to track every little bit of data that I consume, and then make me pay you for that little bit of data. So Hydra might be very powerful for some micropayments like that, for example. This would not work on the layer 1, and so yes, this is a very interesting solution. We can also look at some other tutorials like this. This might be my recommendation of what you guys might want to look at after taking a look at this, because this tutorial gives us a few participants. You can look at what a Hydra head looks like if there are multiple participants involved. So we can see making 2 top participants and generating their keys. And this is a more very, very hands-on tutorial. So I would look at this one because you will find a lot more information about how Hydra nodes work. So you can also see the different configurations you can do. Once you understand all of these configurations and play around with these transactions, you should have a really, really strong understanding of how Hydra works. So yeah, that would be my recommendation. If you would like to look at the code that I wrote for this demo, it is here. So it is in this repository. I will put a link to it a little bit later once we get into the Q&A. And if you look at the branches and switch it into the Hydra branch, you will see the front-end example that I just made, which is this one here. Hopefully that's been helpful. I'm not going to quite take up that much time, but let's open the floor up to questions now. And I'm going to stop presenting. Nidhi, are you there? Or
Yes, Ty, we do have some questions as well. Which is, what signs tell us that Hydra head is running correctly and ready to accept transactions?
sure. So one of the issues with running a Hydra node is that you need to keep communicating with it. So it has a WebSocket connection that I showed you previously. The WebSocket connection will continuously give your backend some information. So if you really wanted to make a Hydra app really well, what I would do is make a WebSocket connection with the Hydra node and continuously pass these WebSocket messages, and the messages will tell you the status that the Hydra node is in. And it's very clear when the Hydra head is running and ready to accept transactions, because the Hydra head sends you a message saying the status is open. Once the status is open, you can begin to send transactions. You can also see in the Hydra TUI that I showed you, which was the visual representation of the Hydra network, the head status was also very clearly visible at the top. So if you just run a Hydra TUI, you will be able to see that too.
Okay. We have a query here from Senthil is, heard there was an incident where the Cardano chain was broken and the person has to apologize. Will Midnight and Hydra solve those issues?
So unfortunately, that's going to be a no. If there are issues with the Cardano blockchain, then Hydra won't be able to function, because, as I mentioned it before, we have to go through those 6 layer 1 transactions. So Hydra actually operates on the assumption that the Cardano blockchain is working well and is not broken. If the Cardano blockchain is broken, there's nothing we can do. In fact, the whole idea is that the layer 1 Cardano Cardano blockchain is much more secure and less likely to break, and that's why we're using it for the security layer instead of the speed, the transaction layer. Unfortunately, yes, you did hear correctly. The Cardano chain had some issues. It was not quite broken, I would say. Essentially, there was some bug in the Cardano, one of the versions of Cardano node, and some of those Cardano nodes ended up validating a invalid transaction and causing a really not fun fork. But that's been resolved, and yeah, everyone just had to update their version to the correct one, and it's now functioning fine. But there definitely was a little bit of downtime. The block production slowed down a lot. Unfortunately, that's just the way it goes. The actual real solution for this happening is having multiple node implementations. So there are a lot of people in the Cardano community now trying to make a new node implementation within Rust. So once that happens, the probability of the Cardano node having a bug and creating this really bad forks is very low, because there will now be 2 implementations of the node, and hopefully that resolves this issue. Yeah.
Thank you. We have another question, which is, how do you see the future of Hydra while considering evolving tech in blockchain?
Very good question. Essentially, I personally think that Hydra isn't going to be the solution for every single app, because Hydra is very specific for very fast and cheap transactions. But you actually do lose some of the decentralization guarantees of the Cardano layer 1. So there might be many different apps inside blockchains, some of them requiring very fast and cheap transactions. And that those apps would use Hydra, while apps that don't actually care too much about speed and efficiency can simply use the layer 1 and not have to use Hydra. But I will say that the majority of use cases, of payment use cases, which is what blockchain seems to be going towards nowadays, does require very fast and cheap transactions. So one of the examples that I said was micropayments. So you can keep track of something like I'm consuming bits of data while I'm on my mobile phone, for example, and you can charge for every single megabyte instead of charging every month or something like that.
Okay. Will using Hydra in the long run make hacks and attacks probable?
No, it won't. The really, really amazing thing about Hydra is that if you run the Hydra node for a long time, you would expect the memory capacity of the Hydra node to go higher and higher. So you would expect the Hydra node to take up more memory because it's storing many of those states. However, Hydra has this really interesting aspect to it where you can actually delete any states that you can any state that isn't the latest one. You only have to keep the most final state. And so if you set up your Hydra node correctly, you can run it forever. And actually the probability of hacks and attacks is very, very low. Like the only way that you would get hacked would be someone going into your server and finding your private key. I mean, that is a possibility no matter what you're doing inside blockchain. Like if you're doing anything on blockchain, you have to keep your private key private. This is rule number one. you have to do that. But Hydra does not make this probability higher or anything. It's just a problem inherent to blockchains. You have to keep your private key private.
We have some pre-submitted questions as well, TY and Sharon, that we would like to address. What does closing a Hydra head actually do? And what parts of the final state get committed back to the test net?
Good question. So closing the Hydra head essentially posts onto the Cardano layer 1. Here is the final state of the Hydra head. So what we're doing is like sending a message to Cardano saying, hey, this is the final state of my Hydra head. These are the UTXOs that I want to finish the Hydra head in. Save it. And what it does is it saves that state. And then it allows a contestation period. What is a contestation period? Essentially, if the participants of the Hydra head looks at the state that you posted onto the Cardano layer 1 and goes, hey, that is not correct. Actually, it is this state. And it will update that state on the layer 1. And if everyone agrees that, okay, now this is the final state, then it moves on to the fan out state. So after the contestation period, which was about 1 minute for my demonstration, you essentially only can replicate the exact same state that you submitted to the Hydra head during the close transaction. So what we saw earlier was the fan out giving my Eternal wallet 100 ADA. So it basically made those 5 separate transactions where I gave 5 ADA, 5 ADA, 5 ADA, 5 ADA, and 80 ADA into one singular transaction that just gave me 100 ADA. So that is actually what is happening in the close transaction.
Got it. Another one we have is if we want to adjust Hydra settings, which parameters are safe for beginners to change without breaking the flow?
That is a little bit of a difficult question for me. I think initially you can try to change the number of peers. So the very the interesting part about Hydra is if you have multiple participants, what happens? So what you can try and do is increase the number of Hydra nodes that you're running, increase the number of peers initially, and just play around with how that works. During inside the Hydra.family documentation, you can see you can try and add peers to the Hydra network that within the tutorial, and yeah, just play around and see how it works. You can also try and update the contestation period, maybe because I put 60 seconds. You can try and put 30 seconds, for example, and just make some little bit of changes here and there and try and learn how it works. That's a very good way of doing it.
Got it. Another one we have is what is the simplest contract we can deploy inside a Hydra head to see the difference in speed and cost?
If you wanted to interact with smart contracts on inside the Hydra head, you can. It is the exact same as interacting with smart contracts on the layer 1. There's no differences in how that works. I'm not sure how I can answer the simplest contract. Maybe an always succeed contract would be as simple as it gets. An always succeed contract just always says yes, you can spend. But yeah, I would actually start with an always succeed contract. And actually, if you look at the icon documentation, you should be able to find very simple contracts that you can deploy onto the blockchain. I think if you can go through the icon documentation and the Hydra documentation and figure out how to deploy a smart contract onto the Hydra head, that would be a very, very good first step to building a really serious dApp inside Hydra. But because Hydra is so good at payments, you might not even need smart contracts within Hydra. Like you might just be able to make a payment app and you don't even need smart contracts inside. Yeah.
Okay. If multiple people participate in the same head, how do we verify that everyone sees the same state before closing it?
That is an amazing question. An amazing question. Yes. So that is actually the security guarantee of Hydra. Every single state that we have gets signed by all the participants of the Hydra head. So let's say that we have 4 different participants. If a state is to be valid, it has to be signed by all 4 participants within the Hydra head, all of them. And so if you've signed a state, then the assumption is that you know what the state is. So that is how we guarantee that all of the Hydra heads see the same state. However, that is actually where the attack vector is, because every single state is signed by all the participants of the Hydra head, which means they're all valid states. Every single one of them, even the ones that are old and not the latest one. So this is actually where the attack vector is, because I can close the head with a really old state. What that means is, like, let's say the final state has the 100 ADA going to my Eternal wallet, but the initial state had the 100 ADA going to some other wallet, right? I can actually close the head in the initial state. There's nothing against that. It is a perfectly valid state. It is signed by all participants and is valid. However, that is where the contestation period comes in, because when the contesting happens, I can submit something to overwrite this older state with the newer state. So yeah, that's the security guarantee of that contesting period. If your contesting period is too short, you might actually have this vulnerability.
We have a live question as well. Can I integrate with Midnight Network for transaction alone? And do I need two separate wallets for Midnight, Lace, and Hydra, Nami?
So the Midnight Network is actually a completely separate blockchain to Cardano. From my understanding, Lace will support Midnight, but Midnight has nothing to do with Cardano or Hydra. Yeah, I just want to clarify that it's a completely separate project. It's basically a separate project built by the same people that built Cardano, and we are using some of the utilities of Cardano to help Midnight function better. But Midnight in reality has very little to do with Cardano and Hydra.
Got it. Another pre-submitted question was, when something goes wrong inside the head, what debugging step still works even though the execution is off-chain?
So when something goes wrong inside the Hydra head, your best bet is simply to close it. Because every single time a state updates, you have a valid state to close the Hydra head in. So if something goes really, really wrong, you should simply take the latest state and just close the Hydra head in that state and just open a new one. Because you're absolutely right, it can go really wrong. Essentially, the states of the participants can vary like wildly. For whatever reason, someone loses their state. Maybe their machine goes offline, their data gets corrupted, something along those lines. If something goes massively wrong, then any participant with a valid state, the latest valid state, just close the Hydra head and start a new one. That would be my recommendation. But Hydra actually does operate on the assumption that your backend is backed up. Like if you lose all your states, then there's nothing Hydra can do. There's no security guarantee for if you simply like have corrupted data. Yeah, there's nothing. Yeah, there's nothing stopping that from happening.
Okay. Um, I think we have covered almost all of our questions for this session, TY and Sharon. But I would like you guys to, just share a quick pro tip from your experience, both of you, if you can, with the participants, which can, help them or, boost them for the finale?
Yeah. So on my side, have I have a really good understanding that Cardano development is not easy. Um, it's a really challenging process to learn all of these concepts about blockchain, about UTXOs, about Cardano, about Hydra. These are all very complicated topics. But the one thing that has helped me learn the best was simply to take really, really small steps. So when you first start, just get the tutorial working. Look at any of the tutorials on any of the documentation websites, get the tutorial working, take really, really small steps, change a very small thing about the tutorial. Like I said, add a peer inside the Hydra head. When you go through the icon tutorials, make a small change, change the private key that signs something along those lines. Make really small changes and start learning about these really complicated topics. And hopefully you can very rapidly build the skill set needed to build those apps.
Okay.
Yeah, and just to add from my side as well. So as TY mentioned, Hydra is very suitable for any kind of use case where a high throughput of transactions are needed. So payments, micropayments are very amenable, but also look into others such as agents use cases. Agents is being talked about a lot. So if you can find an angle there, that could be also interesting, especially because there's the Masumi track as well. So if you see some kind of synergy where you could add Hydra into something that you're building there, that could also make sense. And in general, other use cases where there are lots of transactions that all of which don't have to be posted on the layer one chain itself. Instead, can be done in Hydra, and the final state posted on the layer one can be suitable for Hydra, right? So gaming, for example. That's why earlier on this year we had a big POC where Doom was running on Hydra. That was very successful. So you could look into that for some inspiration and also build, gaming related, gaming related projects using Hydra.
Thank you. Thank you, Sharon, and thank you, TY. Just before we wrap up everything, we have just one live question that I would like to address as well, which is the Lace wallet for Midnight is not working in console. It is showing 503 WebSocket error. Is there any alternative wallet?
I think we're the wrong people to ask that question. We don't really know much about the wallet integration side of Midnight, to be honest.
Thank you. Thank you for answering that. Thank you so much, Sharon and TY, for your invaluable insights for today's session. It was great. Feel free to write down your questions in chat now, or thank you for participating in today's workshop 6. If you have any further questions or need any support, please contact us at support@hacktoskill.com. We're excited to see the scalable dApps you build in the Cardano Hackathon Asia IBW Edition 2025. Thank you, Sharon. Thank you, TY. Thank you.
Thank you.